This is the review video for the Chapter 4 test. Our first question is simply asking us to find the vertex and the axis of symmetry of the given function. So what we first have to do is we have to recognize which form we have. This particular function has been given to us in vertex form. I know that because I have parentheses. Okay, that's the telltale sign. Typically when we have parentheses just like this, we have vertex form. And the reason it's called vertex form is because we can just pull our vertex right out of the formula. So I am going to take my value that is inside of my parentheses and the value at the very, very end of the problem. Now what's important is when we take this value from inside the parentheses, we need to use the opposite value. So my vertex is going to be -2, because I'm taking the opposite of my first number, and then the exact number outside, which is 2. So there's my vertex. It's pulled directly from the equation of the function they gave us. Now, if I have my vertex, my axis of symmetry is a pretty quick find because it will always be the same as the x-coordinate of the vertex. So the x-coordinate of the vertex is -2, which means my axis of symmetry is x equals -2. So in our second problem, we're doing the same type of problem. We have vertex form again, but this time they're asking us to graph. So we've recognized we have vertex form, and we know that because of those parentheses there. We need to create the graph. So our first step is to identify our vertex, just like the last problem. I'm going to have a point. I take the opposite of the thing inside the parentheses, the exact thing outside the parentheses. So 3, 5. That's my vertex. Now my axis of symmetry, again, just like the last problem, is x equals whatever the x-coordinate of the vertex is. So x equals 3. So now we're going to go ahead and we're going to plot those things on this graph. So my vertex is 3, 5. So that's right there. My axis of symmetry goes directly through that point. So now I have a little bit of information on my graph, but not a lot. And I need some more. And the way I get some more information here is by using an XY chart. That's always what we can depend on when we need more information about what a graph looks like. Now, because right now we are at x equals 3, it makes the most sense to stay very close to that. So we're going to plug in 2 and 1 into our XY chart for our x's. I picked my 2 points directly to the left of my axis of symmetry so that I stay nice and close. Okay, so using a calculator or using our brains, whichever way, we can plug in 2 right up here into our original function for x. So I have -3 parentheses 2 minus 3 parentheses squared plus 5. Okay, so let's see what that gets us. 2 minus 3 is -1. And if I square that -1, that becomes +1. +1 times -3 is -3 plus 5 is equal to 2. So my point is 2, 2. So let's go ahead and plot that. 2, 2. And this axis of symmetry is something we can reflect over because we know our function will be symmetric on both sides. So I've reflected that point. And now I'm also going to evaluate for 1. So let's plug in 1 just like we plugged in 2. And again, you can do this in a calculator as well. So 1 minus 3, that gets me -2. And -2 squared is 4. 4 times that -3 gets me negative 12 plus 5, that's negative 7. Okay, so my next point is 1 comma negative 7. So let's plot that. 1, negative 7 is right down here. I'm also going to reflect that. And then I've got my 5 points, so I can create a graph. Now, it's not going to be beautiful. I apologize in advance. But I make a U-shaped graph. It looks something like that. You can see that you have your vertex, which is the first point we plotted. We picked 2 more points and evaluated by plugging them into our original equation. And then we reflected them in order to get 2 more points. Connecting our dots gave us our parabola. Now it's an upside down parabola. This is our vertex. We've got 2 x-intercepts, which would be our solutions. This is my maximum value. Okay, so there's your graph. We're going to move on to the next problem. Now this next problem we're being asked to graph, but then after we're done with the graph, we're also being asked how it has been translated. So that's asking, did it move up or down? Did it move left or right? Did I stretch it? Did I compress it? Did it flip? What's going on with this thing? So we see again, we look at what form we have, and given this problem, we've been given vertex form again. So again, we start with our vertex. We know that our vertex is -2, -4, because remember, you take the opposite of the thing inside and the exact thing outside. My axis of symmetry, we can figure out pretty quickly because it's x equals whatever the x-coordinate of my vertex is. So in this case, -2. I'm going to plot that. So -2, -4 is going to be right about there. My axis of symmetry has to go straight through that point. Okay, but I need more information. So again, we fall back on this XY chart to get some more information about our graph so we can see what it looks like. And if I'm at -2, I'm going to plug in -3 and -4, the 2 closest points. Now I could also plug in 1 and 0. -1 and 0. That'll get me the same answers. Okay, I just tend to pick the 2 to the left every single time I do these problems. So I'm going to plug in -3 and -4. And this time, just to make my life a little bit easier, I'm going to use a calculator. So I'm writing it out so you can see exactly, oops, look at me, I wrote the same number twice. -3, -4. I'm plugging it in so you can see exactly how you would have to plug it in. But I'm just going to plug that into my calculator to evaluate. Okay, so I plugged those into my calculator, and here I get -3, and here I get 0. So I'm going to plot those points. I've got -3, -3, which is right there, and I've got -4, 0, which is right there. I can reflect those to get some more points. And then I've got something that kind of looks like a U, so I'm going to go ahead and connect them. Again, I'm sorry, this is not going to be beautiful by any means. But your graph's going to look something right like that. Okay, so we're done with the graph, but remember, the second part of the question is how has the graph been translated? So I have to ask myself whether it moved left or right, up, down, stretch, compress, etc. So looking at this graph, the easiest way to tell how it has been translated is put your pencil on the origin, right at the corner of X and Y, right there in the middle. And then tell me how to get to your vertex. Remember, your vertex is down here. So to get to my vertex, should I go up or down? Down. And should I go left or right? Left. So I know that this has shifted down. It's actually shifted down by 4. and it's shifted left by 2. Now, did it stretch or compress? You know, it's kind of hard to tell looking at this picture. So what we can do is we can go up and we can look at the very first number that you see, the thing in front of the parentheses. And what do you see there? Nothing. But there is something there, it's just invisible. There's a 1. Now, 1 is the only number where it hasn't stretched or compressed. Okay, 1 is like the no change number. If that number were greater than 1, like for instance 2 or 3, that would be a stretch. If that number were less than 1, like 1/2 or 3/4 or 0.2, that would be a compression. But in this case, it's just 1, so it hasn't stretched and it hasn't compressed. So we do know that it went down 4 and it went left 2. Okay, so we're back to a problem similar to the very first one that we did, where we're only being asked for our vertex and our axis of symmetry. Now, in our first problem, we were given vertex form, which is where you can just pull the vertex right out using the number in the parentheses and the number at the very end. However, we can't do that here, because here we are given standard form. So with standard form, you have to remember that there's a formula that tells you your axis of symmetry. It's x equals the opposite of b over 2a. Now, you must know that for tomorrow. I will not be giving you that formula, so you have to have it memorized. So, well, b and a, what the heck am I talking about? We have to identify what a, b, and c are for this particular problem. So I checked my problem. This is standard form. It is ordered high to low. They're in the right order. They're not mixed around. So I can identify A, B, and C pretty quickly. A is 2, B is 8, and C is -6. So for this problem here, we need to get our axis of symmetry, which means I'm plugging in x equals the opposite of b. So my b right now is 8, so I want -8 over 2 times a, which is 2. So that's -8 over 4, which means x equals -2 is my axis of symmetry. So once I know my axis of symmetry, I know a little bit of information about my vertex, because my vertex is going to be a point, x comma y, and we just learned that our x is -2. It'll always be the same as the axis of symmetry. But how do we find our y value? Well, how do we find our y value? Anytime we have an x, we plug it in. So I need to plug -2 into this original problem that we were given. Sorry, that's supposed to be a 2. So I'm plugging this in to this original equation we were given. Now I'm going to use my calculator again. Obviously you don't need to use a calculator. You can do this in your head, but I'm just going to type it all into my calculator exactly as I see it, using all of the parentheses and everything, and I get -14. So that tells me that my vertex is at -2, -14. And we had already found our axis of symmetry, so we've answered everything for this question. Okay, so I'm going to be graphing another function here. I have to state how it's been translated as well when I'm done. So first of all, we see that here is our function we need to be graphing. I see this is in standard form, so I'm going to identify my A and my B and my C. And then I have to start off by finding my axis of symmetry using this formula. So if I plug in the opposite of B, now my B is already a -6, which means when I use it, I need it to be a +6, over 2 times 3, which is 6 over 6, which is 1. So my axis of symmetry is x equals 1. Now that also gives us some information about our vertex. That tells us that our vertex is 1 comma something. And to find that something, we have to plug 1 in. So I'm going to have 1. I'm going to plug it into this right here. So that'll look like 3 times 1 squared minus 6 times 1 plus 2. And I'm going to put that into my calculator. And I get -1. So I know that my vertex is 1, -1. So I'm going to plot that point. 1, -1. Now, because this is standard form, there's also another point that we get kind of like as a freebie. Because my y-intercept is 0, comma c. And we know that our c is 2. So my y-intercept is 0, comma 2. So we also get to plot that point and reflect it. So I've got 3 points. I've got a pretty good graph, but it could be better. So I'm going to pick one more point just so that I have something super accurate. I'm going to plug in -1 for my x, and I'm going to see what I get. I'm going to plug it in the same way we did before. And put it into my calculator or do that mental math, whichever. And that gives me 11. So I have -1, 11. So it gives off of my paper a little bit, but it's going to be a little bit lower than that, actually. Let me put that point in there again, since that was a little bit off. So I've got -1, 11. I'm going to reflect that. And now I've got some more points. I can go ahead and graph this thing. So let's connect all these. Again, sorry, it's not going to be pretty. But my graph will look something like that. Okay, so now I just have to state how it's been translated. So this graph has moved down and right. Down and right. I had to move down 1 to get to my -1 for my vertex. I had to move right 1. It also has been stretched. And I know that it was a stretch because if I look at my very first number here, my A value, that number is bigger than 1. Anytime that A value is bigger than 1, that means a stretch. Okay, so that's how we've been translated. We're going to move to the next problem. Okay, this next problem is pretty fast. We are given a graph, and we are asked whether the graph has a minimum or a maximum. And then also, what is the minimum or maximum value? So looking at this graph, I see that right here is my vertex. That vertex is always going to be my minimum or my maximum value. In this case, it's -2, 2. So that's going to be my minimum or my maximum value. I just have to determine whether it's a min or a max. Looking at my graph, it is the minimum. If you have a graph that is opening upward, you'll have a minimum, the very lowest value that can ever happen. If you have a graph that is opening down, you will have a maximum because it's the very highest your graph will ever get. So in this case, because your graph is opening upwards, you have a minimum value happening at the vertex, which is -2, 2. Another pretty quick question, what are the zeros of the function? And you're given the graph of the function. So my zeros will always be found wherever my function crosses the x-axis. These are called x-intercepts, my zeros, my solutions, my answers. So right here and right here, you have 2 solutions. Well, those happen at x equals 1, and x equals negative 1, 2, 3, 4, 5. X equals negative 5. That's your answer. All you have to do is identify where your function crosses the x-axis and then state those two values. Here I'm being asked for the domain and range of the function. Now, my domain, every single parabola, every one, no exceptions, the domain will be all real numbers. The range is something that you have to think about a little bit more. So range has to do with the variable y, right? So if I consider my y values, will I ever get to a y value down here? No, because my graph's going upwards. It's going to continue on forever and ever in this direction. It'll never get down here. We'll get here? No. Here? Yes. Here? No. Here? Yes. So where's the breaking point? How do I know? This value right here. This value at y is negative 1. That's your breaking point. Okay? So y, negative 1. Now what you have to decide is, are all of your values above that point or below that point? And just looking at your graph, you see they're all above. So which symbol, the greater than or equal to or the less than or equal to, means above or greater than negative 1? So your range will be y is greater than or equal to negative 1. If you had a graph that is going downwards, like this one, that is when you would use the less than or equal to symbol. Okay, so we're getting into a slightly different type of problem now. We are being asked for the zeros of function, but what we're given is a factored form of a function. So what we need to do is use that zero product property where we set both of these things equal to 0. So I have x plus 8 equals 0 and x minus 4 equals 0. So what I've done is I took my first piece, set it equals 0, took my second piece and also set that equal to 0. And now I just solve. So minus 8, x equals negative 8, and plus 4, x equals 4, and that's my answer. Now remember, there is a shortcut, right? We know that we are always going to be doing the opposite operation to move the number from one side to the other. So it's always going to be the opposite sign. If this is x plus 8, this is x equals negative 8. If this is x minus 4, your answer is x equals positive 4. And that will always happen. You can check your work by doing this, but you can always follow that shortcut when you're doing the solve by factoring. So here I have to do the same thing, solve by factoring. However, they have not given me factored form. They've given me a trinomial, and I first have to factor it before I can solve. So I have a trinomial, which means I know I'm going to have my two sets of parentheses. My variable is x. I look at my terms. I have 3 terms with a plus in the back. So I know my signs will double up like a Wendy's double stack. I'll have 2 minus signs in my parentheses. And I'm looking for factors of 20 that will add to 9. Factors of 20 that will add to 9. So 20, that's 1 times 20, 2 times 10, 3 doesn't work, 4 times 5. Oh, perfect. 4 times 5 adds up to 9. So I have x minus 4, x minus 5. Remember, you can always check your work by double distributing or just checking your inners and your outers. So in this case, I have negative 4x and negative 5x, which is in fact negative 9x. So anyways, sorry, getting back, if you don't want to check your work, which is always a good idea. But you have x minus 4 times x minus 5 equals 0. You just factored that. Now it becomes the problem we did on the last page, where you take the first piece, x minus 4, and set it equal to 0. And the second piece, x minus 5, set it equal to 0. And solve. Plus 4, x equals 4, plus 5, x equals 5, slap an and in the middle, and you're done. So x equals 4 and x equals 5, and remember the shortcut. If this was minus 4, this is plus 4. If this is minus 5, this is plus 5, and you're good to go. Okay, another solve by factoring. So we need to go ahead and factor this thing, but whoa, looking at it, it is all jumbled up. It's a mess. So before I can do anything, I have to put it all back in order, which means my x squared has to come first, then my minus x, then my minus 12, set it equal to 0. Okay, so now I'm in standard form. Now I can go ahead and set up my two sets of parentheses because it's a trinomial. My variable is x. I don't have three terms with a plus in the back. I have a minus in the back, which means my two signs, no matter what they are going to be different. One's going to be plus, one's going to be minus. So now I'm looking for factors of 12 that will subtract to a negative 1. So factors of 12 that will subtract to negative 1. So factors of 12, 1 and 12, 2 and 6, 3 and 4. 3 and 4. 3 and 4 will subtract to give me negative 1. But I need to think, do I want 3 minus 4 or do I want 4 minus 3? 3 minus 4 would give me negative 1. 4 minus 3 would give me positive 1. I want negative 1. So my 4 is going to go here. My 3 is going to go here. And then I'm back to that first problem. So x plus 3 equals 0. X minus 4 equals 0. These are quick solving problems. X equals negative 3. X equals 4, slap an and in the middle, and you are good to go. So there's your answer. Again, remember that shortcut, plus 3, minus 4, plus 4. Again, I'm solving by factoring, but here not only do I have stuff kind of mixed up, but my 14 is on the entirely wrong side. My negative 14 is on the right side, and everything else is on the left side. So he's feeling pretty left out. We have to bring him over by us. So I'm going to add 14 to both sides. That makes this go away. And I have x squared plus 9x plus 14. He just tacks on to the end because that's where he belongs in line, equals 0. Now I have a trinomial. I go ahead and I factor it. So my two parentheses, x and x. 3 terms with a plus in the back. Your signs will double up like a Wendy's double stack. So I have 2 plus signs. And I'm looking for factors of 14 that add to 9. Factors of 14 that add to 9. Oh, there it is. 2 and 7. 2 and 7. Again, x plus 2 equals 0. X plus 7 equals 0. So I'm going to solve, slap an and in the middle, and we're done. X equals negative 2, x equals negative 7. All right, we've got another solve by factoring problem, but what I notice here is that I don't have a trinomial. I now have a binomial. But what's neat is that this is a perfect square, and this is a perfect square, and there's a minus in the middle, so this is difference of squares. Remember, any difference of squares problem is solved the same way. I have 2 sets of parentheses, a plus in one, a minus in the other. I take my 25x squared and I rip it into 5x and 5x. Remember, you take the square root of 25, which is 5, the square root of x squared, which is x, throw those in the front. And then you take your 36 and you rip it into 6 and 6, which is really just the square root of 36. And this whole thing is equal to 0. And you're going to go through and you're going to set each of these on their own, equal to 0, and you're going to solve. So this first one, I'm going to subtract my 6. But I'm not done yet because I still have 5x equals negative 6. And I don't want that. I just want x by itself, which requires division. So I get x equals negative 6/5. That's one of my answers. Over here, plus 6 plus 6. So I have 5x equals 6, but I'm dividing by 5 because I want to get x by itself. I get x equals 6/5. That's my second answer. So this was a little bit different because it was solved by difference of squares, which is where you put a plus in one, minus in the other, and then just split those things where they belong front and back by taking square roots. Here's another solve by factoring. It's a binomial, but it's not difference of squares. Now remember though, the very, very first thing that you should always check for is a GCF. And I do have one here. My GCF is 3, and they both have an x that they can give me, 3x. Both 3 and 9 are divisible by 3, and they both have an x that they can give me, so I'm going to take that away. So my GCF is 3x. What would be left is 3 divided by 3 is just 1. I had 2 x's. I took away one of the x's, but I still have 1 left. And then 9 divided by 3 is 3, and I had 1 x, but I took it away, so there aren't any left. So this was just GCF factoring. So you need to make sure you know how to do that too, taking out your greatest common factor. And now your pieces look a little bit different, but here's my first piece. Here's my second piece. So go ahead and set them both equal to 0. 3x equals 0. Divide by 3. Divide by 3. X equals 0. And x plus 3 equals 0. Minus 3 minus 3. X equals negative 3. So those are your two answers, x equals 0 and x equals negative 3. We determined that because we saw we had a binomial with a greatest common factor that we could take out to the front. Okay, so here we're moving on to the quadratic formula. Now the quadratic formula is also something that you have to have memorized, so let's get that knocked out first. The quadratic formula is x equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a. Remember the story I told you in class was the negative boy couldn't decide whether or not to go to the radical party. So that square boy missed out on 4 awesome chicks, and it was all over by 2 a.m. So you have to remember that formula for tomorrow's test. Got to have it down, got to be able to use it. So once we have that, we need to know what we're plugging in for A, B, and C. So looking at our particular problem, we're going to identify those. So here, A equals negative 1, B equals 8, and C equals 9. Okay, so we're going to plug everything into that quadratic formula. So I've got x equals the opposite of b, so negative 8 plus or minus the square root. Now here we need to make sure we're using our parentheses. B squared minus 4ac all over. Make sure that that is all over. Make sure you don't shorten that line at all. It needs to be all over 2 times negative 1. Okay, so we can use a calculator for this, okay, or we can just simplify the thing under the radical by ourselves. So let's take a look at this off to the side here. we've got square root of 8 squared minus 4 times negative 1 times 9. Well, I know that the square root, I know 8 squared is 64. And then I'm going to bring down this negative, and I cover all this up because I'm not worried about this anymore. I'm just looking at 4 times negative 1 times 9, which gives me negative 36. But if I'm subtracting a negative, that's really addition that's happening. So I have the square root of 100. And do we know what the square root of 100 is? Yes, it's the number 10. So we just simplified this entire mess all the way down to the number 10. So we're going to rewrite this quadratic formula, but instead of this entire radical, we're just going to write the number 10 over 2 times negative 1 is negative 2. Now, because these are all really nice numbers that we know how to work with, there's no radicals, we are going to actually solve for our two answers. We need to take into consideration the case where we add and the case where we subtract. So first we have negative 8 plus 10 over negative 2, or we have negative 8 minus 10 over negative 2. So this would be 2 divided by negative 2, which means x equals negative 1. That's one of our answers. Over here, we have negative 18 divided by negative 2, which means x equals 9 is our second answer. So there you go. We started at the beginning. We wrote out our quadratic formula. We identified A, B, and C. We plugged them in. We simplified our radical by hand. This is something you could also do in the calculator. And then we saw that since we have all real nice numbers that we can deal with, we break it up into our two different cases and solve to get our two answers. So here again, we're using the quadratic formula to solve. So let me write that up here at the top again. The negative boy couldn't decide whether or not to go to the radical party. So that square boy missed out on 4 awesome chicks, and it was all over by 2 a.m. Okay, so I need to identify my A, my B, my C, but hold on. This is not in standard form. So what I need to do is I need to make sure to get everything on one side of the equation. Now, I could do this two ways. I could either move this guy over here to the right, or I could move these two things over here to the left. I'm going to just move one thing. So I'm going to add 2x to both sides. So I added 2x squared, that cancels that, which leaves me with 0 equals 2x squared minus 8x minus 10. Now I have standard form where A is 2, B is negative 8, and C is negative 10. Okay, so plug in. Opposite of B. Oh, so here my B is already negative, so when I plug it in, I want to actually make it positive 8. Plus or minus the square root of B squared minus 4AC. Remember, make sure you put everything in parentheses. And we've got all over 2A. Okay, so I can either use my calculator to enter this entire thing right here exactly as it is, or we can take it off here to the side and go through it on our own. So we've got negative 8 squared minus 4 times 2 times negative 10. So I know negative 8 squared is 64 minus this right here, 4 times 2 times negative 10, that gives me negative 80. And if I'm subtracting a negative, I'm really just adding. So 80 plus 64 gives me 144. And I know that the square root of 144 is equal to 12. So we can just swap out this entire radical for the number 12. So let's do that. Let's rewrite this. Over 2 times 2 is 4. Now again, I have all numbers here. I can deal with these numbers, so I'm going to break it into 2 cases. My case where I add and my case where I subtract, which gives me 8 plus 12 over 4 and 8 minus 12 over 4. So 8 plus 12 is 20 divided by 4. I get x equals 5. And 8 minus 12 gives me a negative 4 divided by 4. That means x equals negative 1. So there's my 2 answers for that problem. Okay, we've got another problem, quadratic formula again. So let's write that down real fast. The negative boy couldn't decide whether or not to go to the radical party. So that square boy missed out on 4 awesome chicks, and it was all over by 2 a.m. Okay, I do have standard form here. This is perfect. So A equals 1, B equals negative 1, and C equals negative 5. Okay, let's plug that in. So I have 1 plus or minus square root of b squared minus 4ac all over 2a. Now again, you can either plug this entire radical into your calculator, or we can take it over here to the side and figure it out for ourselves. Okay, so negative 1 squared is 1 minus 4 times 1 times negative 5 is negative 20. And if I'm subtracting a negative, I'm really adding. So that gives me the square root of 21. Square root of 21. I don't know what the square root of 21 is. So we leave it just like that. 1 plus or minus the square root of 21 over 2 times 1 is 2. Now, I don't have to break it up into my plus or minus case. What I am going to do here, though, is I'm going to break it up into the real part and the radical part. So I have 1 over 2 plus or minus square root of 21 over 2. That's going to be my answer. Yes, there are 2 answers there. I can just leave them together. I don't have to worry about the plus or minus options here. All right, last problem. Quadratic formula again. So let's write it down. The negative boy couldn't decide whether or not to go to the radical party, so that square boy missed out on 4 awesome chicks, and it was all over by 2 a.m. Got that memorized. We are ready for our test tomorrow. We know it down pat. So I look at my problem. I see that I do have oh, no, I don't. Look at these 2 things are in the wrong place. So I just have to kind of swap them around a little bit. I should really have 3x squared plus 5x minus 5 equals 0. So I just moved my 5x and my minus 5. Now I have standard form. Now I can identify A, B, and C. A is 3, B is 5, C is negative 5, and I'm going to plug in. Make sure you use your parentheses here. Okay, just like every other problem, we could put this into our calculator, or we can drag it over here to work on it on our own. Okay, so I know that 5 squared is 25. I'm going to bring down that minus. And now 4 times 3 times negative 5 is going to be negative 60. So I'm going to add these 2 things together. I get square root of 85. Well, again, I don't know what the square root of 85 is, so that's what I'm going to replace that huge radical with, square root of 85. over 2 times 3 is 6. Okay, break your answer up into the real part and the radical part. Remember, both of those things, both of them are over 6. It's all over 6. So this is over 6 and this is over 6. So you have your final answer. There you go. That's the entire review. Good luck on your test tomorrow. Please ask me if you have any questions in the morning. See you then.